In this video, we will try and prove some of the trigonometric properties using vector algebra. The first proof that we would look into is the cosine formulae. So it says that a squared is equal to b squared plus c squared minus 2bc cos a for a given triangle ABC. So let's call this as our triangle A, B, C, and let's define our BC as vector A, CA as vector B, AB as vector C. So we have defined all the vectors here, and then the magnitude of BC can be written as A, and the magnitude of CA can be written as B, and the magnitude of AB can be C. Okay, next we can say, using the triangle law of vectors, that BC plus CA plus AB, because they are all sides of a triangle, then if we sum them all up, it is 0 vector. Okay, so BC is equal to CA plus AB, all are vectors. This is equal to 0 vector. Now, rearranging this formula, we can say, taking the CA and AB to the other side, BC is equal to minus CA minus AB. Next, let's apply dot product to BC, and we'll multiply BC with BC with the dot product. So you have minus CA minus AB, minus CA minus AB for BC, and multiplied with minus CA minus AB. Okay, so it's a dot product. So applying the algebraic formula, which is a plus b the whole squared is equal to a squared plus b squared plus 2ab, we can simplify this as CA squared plus AB squared plus CA into AB. Now, let me just narrate this for you. You have CA vector times CA vector. This will be equal to magnitude of CA times magnitude of CA times cos theta, which is the angle between the two vectors. The angle between the two vectors is 0. So this cos theta will be 1. So your result will be CA into CA. So that is CA the whole squared. So that's why we have CA the whole squared. Similarly, you will get AB the whole squared plus 2 times of CA into AB. All right. Now, further simplifying this, let's apply. We know that CA, magnitude of CA is B. So it's B. And magnitude of AB is C. So applying all the values from here, you get a squared is equal to b squared plus c squared plus 2 times bc into cos of pi minus a. Why pi minus a? Because what's the angle between vector CA and vector AB? Vector CA and vector AB. Now, you have to notice that we didn't take this angle. We don't take this angle, we take the direction. So both the vectors have to be in the same direction. So the direction goes in this way. So this is your actual angle. All right. So this angle is pi minus a. So this angle inside is a. So this angle will be pi minus a. Okay. So we use pi minus a. Now we know that cos of pi minus a, which is cos 180 minus theta, would be equal to minus cos theta. So your answer would be a squared is equal to b squared plus c squared. Cos pi minus a will be minus cos a. So substituting that here, you have a minus 2bc cos a. So we have proved that a squared is equal to b squared plus c squared plus 2bc cos a. Similarly, we can prove the other two using the same method. Next, let's prove the next trigonometric property, which is a is equal to b cos c plus c cos b for a given triangle ABC. So let's sketch our triangle A, B, and C, and let's define BC as vector A, CA as vector B, and AB as vector C. All right, and we will also define our angle here as pi minus A. The internal angle here will be A. So similarly, this angle will be pi minus B, and this will be pi minus C. All right. Now, the magnitude of BC is equal to A, and the magnitude of CA is equal to B, and the magnitude of AB is equal to C. Okay, so we have put it down here. Then by the triangle law, we can say vector BC plus vector CA plus vector AB will be equal to 0 vector. So if I'm going to move CA and AB to the other side of the equation, you get vector BC is equal to minus CA minus AB. Now let's multiply the vector BC with vector BC as a dot product. So when we do that, vector BC dot product with vector BC, and keeping our first BC as it is, but the second BC vector, let's replace it with minus CA and minus AC. So using the distributive law, we can say BC into minus CA will be minus BC dot product with CA, and BC into minus AB will be minus BC dot product with AB. All right, so it's just substituting this on this value of BC, you get this. Then further applying our dot product, you get that BC into BC, as we have seen in the previous example, you will get it as BC vector the whole square, the magnitude, because the angle between BC and BC will be 0 because they are the same vector. So your cos 0 will be 1. So you get magnitude of BC the whole square is equal to, then let's apply the dot product here. BC into CA will be magnitude of BC times magnitude of CA times cos of the angle between BC and CA. The angle between BC and CA is pi minus C. So let's put that pi minus C here, cos of pi minus C. Similarly, minus magnitude of BC, magnitude of AB into cos of pi minus B, because that's the angle between AB and BC. All right. So next, cos of pi minus C is minus cos C. So if you replace that, and replacing BC magnitude with A and CA with B, you will get AB cos C. So you get AB cos C minus our BC is A, AB is C. So A, C, and cos B, because cos pi minus B will be minus cos B. So this minus will become plus here. So further, if you're going to divide the whole thing by A, you will get A is equal to B cos C plus C cos B. So now we have proved that A is equal to B cos C plus C cos B. The same can be applied, and we can prove the other two formula. In the next problem, By vector method, prove that cos alpha plus beta is equal to cos alpha cos beta minus sin alpha into sin beta. Okay, so now let's consider a vector OA, which is a unit vector A cap, and vector OB is a unit vector with B cap, and let alpha be the angle between A cap and the x-axis, and beta be the angle between B cap and the x-axis. So let's draw this. Okay. Next, let's draw two perpendicular lines, AL and BM. Okay, perpendicular to the x-axis. So that's my AL and BM. Now, you will notice we can define OL as OA into cos alpha. How can we prove that? If this is a right angle triangle, triangle OAL, and alpha is the angle for which we need to find the cos, so cos alpha will be equal to the adjacent side, which is OL, magnitude of OL, over magnitude of OA. So we can further derive the magnitude of OL is equal to magnitude of OA into cos alpha. Similarly, we can also, in the same triangle, we can say sin alpha is equal to magnitude of LA over magnitude of OA. So in other words, magnitude of LA will be equal to magnitude of OA into sin alpha. Alright, so I have put this value here and I have put this value here. Okay, so now we know how we got these two values. Due to lack of space, I am erasing this so it's easy for me to explain the next further, as we go down. All right, now let's take the vector OL and call it as the magnitude of OL into I cap. So what is I cap? I cap is, this is your x-axis. I cap is a unit vector in the x-axis, and j cap is the unit vector in your y-axis. Okay, they're not to scale, but just for your reference. So I cap is a unit vector in the x-axis and j cap is a unit vector in the y-axis. So we can define OL vector as the vector OL as magnitude of OL times I cap. All right. So, and we know that magnitude of OL is equal to cos alpha, because OA, the magnitude of OA is A cap, magnitude of A cap, which is 1, because it's a unit vector. So we substitute OL with cos alpha over here, and also we can represent LA, which is this vector here, as sin alpha into minus j vector. So how do I say minus j vector? Because it's in the negative side. It's in the opposite direction. So it is a minus j vector, j cap. Okay. So we have now OL vector and LA vector defined. Next, our A cap by vector algebra is equal to OL vector plus LA vector. Yeah. So A cap is equal to OA is equal to OL plus LA. Yeah. And now let's substitute our OL, which is here, which is cos alpha I cap, and the LA, which is here, which is sine alpha j cap. Okay, so it's minus sine alpha j cap, right? Further, we can define b cap as equal to, which is this vector, OM plus BM. And this can be easily defined as cos beta I cap plus sine beta j cap. All right. So further, if we take the cross product of A cap and B cap, then we can define it as A cap magnitude times B cap magnitude into cos alpha plus beta. Why? The angle between the vector A and the vector B is A alpha plus beta. So it is magnitude of A times magnitude of B times cos alpha plus beta. Now we know the magnitude of A and B is 1. So this is equal to cos alpha plus beta. So let's keep this as our 3. Then let's do the dot product of A and B using 1 and 2. Okay, we're going to use this 1 and this 2 and do a dot product of A and B. So bringing cos alpha I minus sine alpha j here, and bringing cos beta I plus sine beta j here, you get this. Now we know that I cap into I cap is equal to 1, and I cap into j cap is equal to 0. Okay, so you will end up with just 2 terms, because I cap into j cap will become 0 and j cap into I cap will become 0. So you'll be left with cos alpha I cap into cos beta I cap, and I cap into I cap will be 1. So it's cos alpha into cos beta minus sine alpha j cap into sine beta j cap. Again, j cap into j cap will be 1. So you'll be left with sine alpha and sine beta. So we can equate these two. They are the same. A cap dot b cap, A cap dot b cap. So which is cos alpha plus beta is equal to cos alpha or cos beta minus sine alpha sine beta. So we have now proved our trigonometric theorem using vector method. In the next problem, with the usual notations, in any triangle ABC, prove by vector method that A by sine A is equal to B by sine B is equal to C by sine C. So let's consider the triangle A, B and C with vector A, vector B and vector C, and the angles as pi minus B, pi minus C and pi minus A. Then we can define their magnitudes as vector B, magnitude of vector BC is A, and for C it's B and AB is C. Now if you're going to sum all these vectors, BC plus CA plus AB, you get 0, right, by the triangle law. And if I'm going to multiply this with a BC, then it's BC multiplied by BC CA AB, which will again be a 0 vector. The notable thing is vector BC times vector BC will be equal to 0 vector. So you're going to be left here with BC into CA is equal to AB into BC. I can explain it further for you. So this will be BC vector into BC vector plus BC vector into CA vector plus BC vector into AB vector is equal to 0 vector. Now this term will disappear because it's 0. So you will be left with these two terms. And if I'm going to move this term to the opposite side, it will become BC vector into CA vector is equal to minus of BC vector into AB vector. And we know that minus BC vector into AB vector is equal to AB vector into BC vector. So substituting this onto this and moving it to the other side, you have vector BC cross product with vector CA is equal to vector AB cross product with vector BC. Okay, I hope it's clear so far. All right. Similarly, we can apply by using CA instead of BC and cross multiplying that BC CA is equal to CA AB. Just using the same method, you can prove this. So we'll define this as our 1 and define this as our 2. Equations 1 and 2, we get AB into BC is equal to BC into CA. So I'm putting that here. And in equation 2, BC into CA is equal to CA into AB. So we can say that AB into BC is equal to CA into AB is equal to BC vector cross product with CA vector. Now, what is the cross product of AB vector into BC vector? If I'm going to take the magnitude of it. So the magnitude of AB vector into BC vector is equal to AB vector magnitude into BC vector magnitude sine theta, where theta is the angle between AB and BC. The angle between AB and BC is pi minus b, and the vector AB magnitude is equal to c, and the magnitude of vector BC is equal to a. So you can write this is equal to c a sine pi minus b, and sine pi minus b we know is equal to sine pi. So that is equal to CA sine b. Okay. So I can write it as CA sine pi minus b. Similarly, we can prove the magnitude of CA vector cross product with AB vector is equal to BC sine pi minus a, and also for BC vector into CA vector as AB into sine pi minus c, and further simplifying sine pi minus b as sine b, and sine pi minus a as sine a, sine pi minus c as sine c, you get this. And further, if you divide them all by a, b and c, you will be left with ABC. If you divide here, your a and c will disappear. You will be left with b as the denominator. So it will be sine b by b is equal to sine a by a is equal to sine c by c. So rearranging, we have sine a by a, sine b by b, sine c by c. Also, you can flip around the numerator and denominator and write it as a by sine a is equal to b by sine b is equal to c by sine c. Therefore, we have proved our theorem. In our last problem, let's prove by vector method that sine alpha minus beta is equal to sine alpha cos beta minus cos alpha sine beta. So to do this, let us draw vector A and vector B as unit vectors. So we represent them by A cap and B cap, and OA be the A cap and OB be B cap, and let alpha be the angle between x-axis and the vector A cap, and beta be the angle between x-axis and the vector B cap. All right. So you can see the angle between A cap and B cap will be alpha minus beta. Okay. Next, we have seen in example 6.3 that A cap is equal to cos alpha I cap plus sine alpha j cap, and B cap is equal to cos beta I cap plus sine beta j cap. So let's just retain this information. And now the angle between A cap and B cap is alpha minus beta, and we're going to define a new vector k cap. Okay, and this k cap will be in a right-handed system with B cap and A cap. Why? Because we're having the cross. If we take the cross product of B cap and A cap, you will have a k cap which will be perpendicular to A cap and B cap. Is that clear? If I'm going to do a cross product of B cap and A cap, then you will have k cap which will be perpendicular to both A cap and B cap. Okay, so we have a new introduction which is k cap. Next, B cap cross product with A cap can be written in this form. So let me explain that for you. B cap cross product with A cap will be equal to magnitude of B cap into A cap into k cap, where k cap will be the resultant unit vector here. Okay, now we know that B cap into A cap cross product magnitude will be magnitude of B cap into magnitude of A cap into sine the angle between B and A. The angle between B and A is alpha minus beta. So alpha minus beta into k cap. So I have brought this here. Okay, is that clear? So we know that B cap and A cap are equal to 1. Therefore, you will get sine alpha minus beta into k cap. Next, from this A cap and this B cap, we can say that B cap into A cap is the determinant of this matrix here, which would be from the coefficients of I cap and j cap, and from the vector B, the coefficients of I cap and j cap. Now our k cap coefficients will be 0 for both A cap and B cap. Okay, so further simplifying this determinant, you can get sine alpha into cos beta minus cos alpha into sine beta into k cap. Why? The minor determinant of I cap and j cap will be 0, because for example, if you take j I cap, the minor is sine beta 0, sine alpha 0, and the determinant of this will be 0 minus 0. Similarly, for j cap also it will be 0. So you'll be left with sine alpha into cos beta minus cos alpha into sine beta into k cap. So by applying the two equations, we can say from here and here, which is sine alpha minus beta k cap is equal to sine alpha cos beta minus cos alpha sine beta into k cap. So this is the magnitude. So these two are equal. So we can say sine alpha minus beta is equal to sine alpha cos beta minus cos alpha sine beta. So hence the proof. Thank you for watching Math Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.